Sorry, I got started before I hit record. So, we have a matrix here, and we are going to find the eigenvalues, lambda 1, lambda 2, the eigenvectors, v1 and v2, then S, the diagonalization, and S inverse. And then we're going to show that it really does equal the matrix. So, all right, I already got started. So, the first thing to do is take the determinant of A minus lambda I. Okay? So, that's 6 minus lambda times 3 minus lambda, and then plus 2. Okay? So that would equal 18, and then negative 3 lambda, negative 6 lambda is negative 9 lambda, and then plus lambda squared, and plus 2. Okay, so that doesn't have the prettiest picture right there, so we'll reorder it. Lambda squared minus 9 lambda, and then plus 20. Okay? Okay, so I got to factor this. So the way I would factor it is lambda minus 5 times lambda minus 4, and we're going to set that equal to, we're going to set that equal to 0. So, lambda 1 is going to equal 5, and lambda 2 is going to equal 4. Okay? Okay, so we found lambda 1 and lambda 2. Now let's find v1 and v2. So, to find v1, first we're going to look at a minus lambda 1I. Okay? And so that would equal, right, so that's 6 minus 5, negative 1, 2, and 3 minus 5. Okay? So 6 minus 5 would be 1, negative 1, 2, negative 2. Okay? And you see, just like on previous problems, that I can eliminate the entire bottom row using the top row. So, the problem we really get down to is this question right here equals 0 and 0. And so v1 would equal, okay, so that would just be 1 and 1. Great. So we found v1. Okay, now let's find v2. Okay? So for v2, we're going to be looking at a minus lambda 2I. Okay. So a minus lambda 2 would be 6 minus 4, and that would be negative 1, that would be 2, and that would be 3 minus 4. Okay. Now 6 minus 4 would be 2, that would be negative 1, and that would be 2, and that would be negative 1. So yeah, we completely eliminate the bottom. Okay, so we can completely eliminate the bottom, and let's go ahead and let's divide by 2. So this is going to be 1, negative 1/2, 0 and 0. Now acting upon v2 is supposed to produce 0 and 0. So v2 is going to equal 1/2 and 1. Okay. Okay, so let's see where we're at so far. So we're at S is going to equal 1 and 1 and 1/2 and 1. Okay? And the diagonalization matrix is going to equal, which we're going to get first, 5. 5, 0, 0, 4. So our last step in the problem, we have S, we have the diagonalization matrix. Now we're going to look for S inverse. Okay, so let's set this up and let's find S inverse. 1, 1, 1/2, 1, augmented 1, 0, 0, 1. Okay, so I take the top row times negative 1 and add 1, 1/2. Okay, 1, negative 1, 1, 0. Okay. That would be a 0 right there. And so if I take that guy and I multiply it by -1/2, by -1/2, I'm going to get -1/2. -1/2 plus 1 is a +1/2. Okay? Okay, so I'm going to go ahead. You know what? We got a negative. If we multiply the bottom by -1/2 upwards, that's a good step at this point. Don't go ahead and kill off 1/2. So yeah, let's just do that. So times -1/2 and upwards. So that would give me 1, 0, 0, and then 1/2, and -1 and 1. Okay. So if I multiply that guy by -1, it's going to turn into a +1. +1 plus 1 is 2. Okay, if I take that guy and multiply by -1 and that upwards, that's a -1. Then I got to take this one and I got to multiply by 2. 1, 0, 0, 1, augmented with 2, -1, -1, and 1. All right, now before you go through the whole process of multiplying out S diagonal and S inverse, it's a good idea to go ahead and multiply S and S inverse, make sure they actually do cancel each other out. So, 1, 1, 1/2, 1, sorry, -2, 2, okay? All right, now acting upon 2, -2, -1, and 2. Okay. So, 1 and, all right, so that'd be 2 and -1, so that'd be 1. Then 1, acting upon that guy would be -1, acting upon that guy would be a +1, that's a 0. 1 and 1, acting upon 2, -2, that's already a 0. And 1 and 1, acting upon -1 and 2, yeah, that's a 1. Okay, good. Right. So we found an S inverse. Okay? All right, now as the last step, let's check our work and let's multiply S diagonal, S inverse. So, S diagonal, S inverse is going to equal, so that's going to be 1, 1, 1/2, 1. Okay? And then this is going to be 5, 0, 0, 4, and this is going to act upon 2, -1, -2, and 2. Okay. So that would be 1, 1, 1/2, 1. Okay. That would be 10, -5. That would be -8 and 8. Okay, now 1, 1/2 acting upon 10, -8. That would be 10 and then -4. So 10 minus 4 is 6. Okay, 1 and 1/2 acting upon -5 and 8 would be -5 plus a 4. So that would be a -1. Now 1, 1 acting upon 10, -8 would be just 10 minus 8, which is 2. And 1, 1 acting upon -5, 8, that's just -5, or 8 minus 5, which is 3. And that's what I started with, right? 6, -1, 2, 3. Yes, so we did get back to where we started. We found the eigenvalues, the eigenvectors, S, the diagonalization, and S inverse.